View,
Yeah, start.
Started? So now I am going to describe the hardware features of this mobile mounted pendulum. So the chassis has been completely manufactured out of aluminium for its lightweight and strength. Okay. We have chosen a specific type of alloy which is used in aircrafts and bridges, which has manganese and other additives for extra strength. So the design has been done using CAD tools. Now we'll look at the electrical and electromechanical features of this system. First, we'll see the motors. So these are the two motors which are used to drive the system. So these are from the company Maxon motors. So they are 120 watts each. So this portion is the actual motor. So this is the gearbox. So and there is a small encoder being attached to the end of the motor. So the encoder is the sensor which senses the angle of this motor, and the wheel has been directly connected to the shaft of the motor. So now the encoder is of an incremental type. So it provides a 2-channel of square pulses for during the rotation of the motor. So this one has a 256 pulses per rotation of the motor. So this since the power is quite high, this has very good capabilities and it can lift up to 5 to 10 kgs of payload. Okay. Next we'll look at the motor drivers. Okay. So these are the two motor drivers from the company Maxon motors. So these have capabilities up to 50 volts and 5 amperes of motor. So this motor is currently 24 volt and consumes max of 5 ampere. So these motor drivers are quite miniature and they don't have much power dissipation. And these motor drivers have been configured in such a way that the processor has to be turned on first, which provides it the PWM signal, and then the power has to be given to the motor drivers. So if the motor drivers are switched on first and then the processor is switched on, it has been built in such a way that it actually refuses the signal. So the power up sequence is first the processor has to be powered, then the power has to be given to the motor drivers. So this system now has two batteries. One is a 7.2 volt battery and the other is a 24 volt battery. So the 24 volt battery is used for powering the motors and the 7.2 volt battery is used for powering the processing circuits, the Zigbee transmission module and other inertial measurement unit and other modules. So there are two regulators. So one converts the 7.2 volt to 5 volt for circuit purposes, and there is a 3.3 volt regulator which converts the 5 volt into 3.3 volts for the PIC microcontroller and the Zigbee module. And there is another regulator on the other side, so which converts the 24 volt into 12 volt for any other expansions like cameras or lidars and many other peripherals. So the inertial measurement unit, which consists of a 3-axis accelerometer, a 3-axis gyro and a 3-axis magnetometer, is mounted as close as possible to the point of rotation, which is the line connecting the center of two wheels. So this inertial measurement unit is the one which is used to calculate the pitch angle, which is the central body angle, and the rate of the variation of central body angle, which is called pitch velocity. So this has a very sensitive connector and it has to be mounted very carefully. So we have taken proper care and it has been fixed with glue such that the vibrations of the system does not affect the connectivity. Next, the processor used is a PIC microcontroller. So this has floating point capabilities. It's a DSPIC version. So this one has lots of other peripherals inside it. For example, the serial peripheral interface, or the SPI, is used to interface it to the inertial measurement unit. The UART is the universal asynchronous receiver and transmitter, is used to connect the Zigbee wireless transmitter and receiver module, and it has a PWM unit which generates the PWM pulse width modulation signals for both the motor drivers, and it has ADC capabilities which continuously monitors both the battery voltages, and further it also gets the encoder pulses and it converts the pulses into a count, which is a representative of both the wheel angles. That's it.